Hey there, in this lab we are looking at Archimedes' principle, water displacement, and the buoyant force, which is an upward force that is applied to an object when it is either partially or fully submerged in a fluid. Remember, a fluid can be not just a liquid, but also a gas or plasma. In this case, we're going to be submerging an object, two different objects, a 500 gram mass and also a 1,000 gram mass into water. And we're going to see how much water is displaced, how the force pulling down on our object appears to change because of this upward buoyant force, and relate that to Archimedes' principle. We will take some measurements of mass, weight. Remember, weight is the force of gravity pulling down on an object. And we will also take measurements of the amount of water displaced or moved out of the way by an object that is being submerged in that water. To get precise measurement of the amount of water being displaced or moved out of the way, we have some more precise graduated cylinders over here that give us readings in milliliters of how much volume a certain amount of water takes up in space. We also have a spring scale over here we're going to use to get the amount of mass of our objects and also to see on the other side their weight. Remember that our weight is just the force of gravity pulling down on our object, and that weight is just the mass multiplied by little g, the acceleration due to gravity. But we have a tool that can take all those measurements for us. Before you begin in viewing the rest of the video and collecting your data, make sure you do read over the lab guide. All you're completing for this lab is the lab guide, which I should be showing now on the screen, Archimedes Principle Lab. Make sure you read this very brief overview at the top. We're investigating Archimedes' principle, water displacement, and the buoyant force, and basically what happens when we submerge something in water. Make sure you complete this. Put in any predictions that you have here with justification. At the bottom of that first page, draw a quick diagram of the experimental setup, which I'll show you in detail in a moment on the camera. Do your best to insert a diagram. There are different ways. If you're editing in Cami, you can kind of use the pencil drawing tool to put in something of a diagram, or use the shape functions to put in something and label what you see on the screen. Do the best you can digitally. And then just down here list the materials that we're using. Again, we'll go over what's in the setup in just a moment. There are two main parts, part one and part two. This is a very specific procedure, especially needed for those doing it in class when they need to put all this stuff together. But you'll see me going through this procedure. In the first part, we are just looking at what the mass and weight of our objects are when they are out of the water, and then when they are put into the water, and we'll record that down here in our data table. What is the mass in grams and the weight in newtons when our object, in this case the 1 kilogram block, our bigger one, when it is in the air versus when it is submerged in water. We'll do the same thing again for our smaller block, the 500 gram golden looking block. What's its mass and weight in air, and then when it's submerged in water. Basically, this is basically a diagram of the setup here. I have a spring scale right here, which is going to be supporting our object, each of them one at a time. So we'll take our measurements when our object is out of the water with the spring scale right here. We got some support stands and rods holding it up. And they got a beaker full of water down here with a little tray to catch any spillage underneath of it. And then we lower the contraption. We lower this support rod down so that the object is completely submerged in the water. But just the object, not the scale. The scale won't be in the water, just our object. But our object also will not be touching the bottom of the beaker or container. It's still going to be suspended in the water by the scale, and just the object, our block, will be in the water. Part two, we are going to look at the actual amount of water that is displaced or pushed out of the way by our object by letting our container overflow, and we'll collect the overflow amount, and we will record that over here for each of our objects, the 1,000 gram and then the 500 gram weight separately. We'll see how much water do they push out of the way in milliliters. We'll use our graduated cylinders to collect that data. And an important thing you can remember here is that 1 milliliter of water has the mass of 1 gram. So if our 1,000 gram weight displaces or moves 500 milliliters out of our container, then that means we have moved 500 grams of water out of the container, because 1 milliliter is equal to 1 gram of water. And then we have reflection questions to answer at the end. Okay, so we'll go back to our first part now. Switching back to our camera view, I'll show you the overall setup. We have our two masses, our two objects, which are the golden weight here, which is 500 grams. That's the smaller one. And then our 1,000 gram or 1 kilogram weight here. We'll start with the heavier 1 kilogram one. I've got a 600 milliliter beaker that's filled with, it's not going to overflow just yet, but it's enough water to submerge our blocks in. Our protective kind of overflow tray down here, we have our spring scale. On one side of the spring scale, you can see this is in newtons, and there are measurements on the side up to 10 newtons of force, so we can use this to measure the weight or the force of gravity pulling down on our block. It's just a spring in there that's calibrated to tell you how much force is pulling on it, and a hook to hang stuff from it. So that's the force measurement side of the scale, and when we turn it around, it converts it into grams. So if we wanted, this is like using the triple beam balance, except you just hang something from the spring. You can see that there are numbers on the side, if it focuses, going from 0 up to 1,000 grams at the bottom. So it's showing us what is the mass. There we go. What's the mass of the thing hanging from the bottom on this side? That's in grams, so you're looking at the G right there. And then on this side we have the force in newtons, which is going to be the weight. And we're just going to hang that from our contraption right here. And when we lower our whole contraption, this will be able to have our weight or block hanging from it, and it can lower into the water. And right now we have this much water in our beaker. It doesn't matter how much we have right now, we just want enough to submerge our object. Alright, we're ready to get started with part 1. And what we're going to do is take our 1,000 gram or 1 kilogram block, and we're going to hang it from our spring scale up there. And first we're going to record its mass. Look at the data table and see what units I want you to record the mass in. So I just hang it like that so that it's not moving. And I'm going to make sure it's not touching my container there. So notice that it's not in the water. It's above the water. It's just hanging there, not touching anything. And so when we go to take a measurement of its mass, we can look at this side over here that has the grams unit to see what the mass of our object is. And when you're reading this, you're looking at the bottom of that brown piece right there. So you see that's got this brown piston basically, and or maybe that's beige, I don't know, whatever. But that brown colored thing, when at the very bottom, you see it's the very bottom of it is pretty much exactly lined up with the 1,000 line mark, or 1,000 gram mark. So we're looking at the bottom of that brown thing that kind of flanges out, kind of like a trapezoid at the bottom. Alright, so our mass here of this guy is 1,000 grams, which is what it should be, because that's what I said, it's a 1 kilogram block. Alright, so there's our mass, and we're hanging it in the air. We haven't gone into the liquid yet. And here this side, this is our newtons of force side. So again, we're looking at the very bottom of our brown piston there. And once it focuses, we can see where it's at. It looks like it's pretty much at the 10 Newton mark. Maybe slightly less than 10 newtons, 9.9, but that's, you'd round that to 10. That's 10 newtons, so that's its weight in the air. Alright, so now what we're interested in doing is submerging our block in the water, and we're not going to let this 1,000 gram block actually touch the bottom of the container. It's not going to be supported by the table or the container. It's still going to be suspended, but it will be in the water. So I'm going to carefully unscrew the top and lower this whole thing down. until our block is submerged. Here we go. Try not to break anything during this process. You can see I'm lowering it and lowering it and lowering it. And if you keep an eye on the spring scale, you might notice that it's actually changing its length. But let's get it submerged. There we go. And tighten back up again. Alright, so let's just make sure we can see that our 1,000 gram block is completely underwater. None of it is above water. Okay, it is completely underwater, but I've made sure not to put my whole spring scale in there. And then also down here at the bottom, it might be kind of hard to see, but there is space in between the block and the table. So it is not touching the bottom of the container. It's suspended in the water. So now we'll take our new measurement. What is the apparent mass reading here for our 1,000 gram block? It's 1,000 grams in the air, but now it's submerged in the water. Its mass appears to be, so we focus, remember we're looking at the bottom of that brown piston there. There we go. So that's a little less than 900. Look what each of those small tick marks represents. So it's somewhere between 800 and 900 grams. Okay. And we have one, I'm counting the small tick marks, 1, 2, 3, 4. So each of those small tick marks is another 20 grams. So we've got, way up there by 800, we go 820, 840, 860, 880, and then 900 grams. So that is probably, I would round it to 880 grams. I'll let you take the measurement for the next one. Rounding it to that closest small mark that we can see. Each of those separations between the small marks is another 20 grams. Okay, so there's the mass, what appears to be the mass of our block when it's submerged in water. It actually still has the same amount of mass. We haven't destroyed any of our block here, but now our spring scale gives us a different reading because there's a buoyant force pushing up a little bit. Now we're doing the force reading in newtons. So let's see if we can get this to focus. Looks like it's between 8 and 9 newtons. Once it focuses, we can get a better reading. There we go. Again, each of those tick marks is going to be the same separation as on the other side. So following the small tick marks after 8, going downwards would be 8.2, 8.4, 8.6, 8.8, and then 9 newtons down there. So that looks like 8.8 newtons, which is its weight when it is submerged in the water. So it seems to have a lower mass and it seems to have a smaller weight when it's submerged in the water, because now when the water, there's a buoyant force pushing up on our block, making it seem like it weighs less, which is why something feels less heavy if you try to lift it underwater. Alright, that's the first part of part 1. We're going to do the same thing with less talking for our 500 gram block and see how that changes. So I'm going to remove this one. Let the water go back into my container. Put that to the side. And now I have my 500 gram block. This is the one that says 500 on it. And we're going to hang that from right here. So we know our spring scale on one side should show us the mass. Now we're hanging it in the air, it's not in water. And we go to look at the mass amount. It should be 500 because that's what this thing is supposed to be. Actually, it looks like a little bit more. So you can record, looks like a little bit more than 500 grams. You decide what measurement that is. Looks like it's one tick mark below the 500, the bottom of the brown thing, just before the spring coil starts. And then we got to look at our weight, which is in newtons on the other side. Again, that looks like a little bit more than 5 newtons. Looks like it's down to the first tick mark after the 5. Alright, and then we're going to submerge this guy. Let's see if we can get a better view of what's happening to our spring scale as we lower it into our water. And I want to make sure I'm not letting it touch the bottom. Looks like it's touching the bottom a little bit, so we got to bring it up. Oh, there it is. You can see it kind of swinging around underwater, so I know it's not touching the bottom. Alright, so now we've got as much of our block as we can have submerged. This is our 500 gram one, and now we're looking at what is its mass according to the spring scale. Now that it is submerged, there we go, somewhere between 400 and 500 grams. Looks to me like 3 tick marks or so below the 400 mark. That's in grams, so that's its mass submerged in water. And then on this side we got our force in newtons, somewhere between the 4 and 5. Again, looks like 3 tick marks below the 4, so 4 point something newtons, which now seems to be its apparent weight when it's submerged. Again, its weight is less because its actual weight isn't less, but it appears to have a lower weight because the buoyant force is pushing up a little bit on the block. This is part of our Archimedes principle. So there is our part 1. We did that for both blocks. Our part 2, we're going to fill up our container all the way and then lower each block one at a time, lower each block into that completely full container and let all the water that can overflow, and that will be the displaced water. And then we'll see what the volume of that displaced water is. Again, when we find the volume of that displaced water, we'll find it in milliliters. And like I mentioned before, 10 milliliters is going to be 10 grams of water. So we can actually know the mass as well of that water that's displaced. So we'll go fill up this container and continue with part 2. So in part 2, we're looking at the amount of mass of the displaced water when the weights are submerged. So we need to find out how much water is displaced and then what is the mass of that displaced water. And we'll do that for each object, the 1,000 gram and 500 gram object. What we're going to do is, now that I've filled up our beaker, it's all full, and we still have our spring scale up there that we will use to slowly lower our object into the water. I'll probably do it by hand, actually, that lowering process. And you see there's a spout right here on our larger beaker. So I'm going to place this smaller beaker just below it so that any water that spills over will come out the spout of the big beaker and go into the smaller one. And this doesn't have very good measurement precision. It's very hard to get a good volume measurement from one of these beakers. So then we'll use our good graduated cylinders. I'll pour what spills out. We'll pour that into our graduated cylinders to see what the precise amount of displaced water is. So I'm going to start with the bigger one, the 1,000 gram one. I have it attached to my spring scale now, and we're going to lower it in at a constant speed so the water just seems to pour out without going over the edges. I want it to just come out of the spout. Otherwise I'll lose some of the displaced water. Looks like I'm doing a decent job so far. And now we're all the way in there, and our smaller beaker has collected the overflow. So notice how the water level in the big beaker changes as I submerge. I get water being displaced, and I submerge it all the way now, and my beaker is not overflowing anymore because I've collected all the overflow water. So everything that overflowed is water being displaced by this guy, this weight. And the volume of water displaced should be the same as the volume of the object I just put in there. So here's how much water was displaced. We can take a look at the measurements readings on the side. It looks like 125 or so milliliters, but like I said, this isn't a very good measurement tool. It's not very precise, so we're going to use our graduated cylinders over here to get a better reading. Instead of refilling them, emptying them, I'm just going to use 3 of them if we need to. Here's the smallest one. We'll start with our one in blue here. Oh, let's do the one in white, it's easier to read. So we're going to carefully pour in our overflow water that we collected into this graduated cylinder, because we want to know as precisely as possible how much water overflowed. Now this graduated cylinder goes up to 100 milliliters, so I'm going to fill it to 100 as best I can. And you remember perhaps from August, back when we talked about graduated cylinders, there's kind of a curve to the liquid when it's in the graduated cylinder called the meniscus, and that's where we do our measurement of the volume from. Hard to see with our camera here, but this is now 100 milliliters. Okay, and I still got some left over, so we got 100 milliliters that overflowed. Put that to the side, and then we'll use our smaller one to see what the remaining amount is. We'll move our gauge out of the way. There we go. Alright, so now we got the remainder of our overflow water. Alright, there we go. And now this is the one that we want to measure as best we can. I think we can probably see it best, perhaps. This. Alright, so you see the curve there in the water, it dips down in the middle. That's the meniscus, is the bottom of that curve. So we are 10 milliliters is this line that goes all the way around. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see from 10 to 20, each of these small lines is 1 milliliter. Okay, so we've got 10, 11, 12, 10, 11, 12, and it actually looks like it's in between the 12 and 13 mark. Kind of hard to see, I think, in the camera. Well, it's not that bad. 10, 11, 12, 13. So I'd call it 12 or 12 and a half milliliters here. So we're adding that, whatever you decide to record, we're adding that 12 or 12 and a half milliliters to our 100 milliliters we already filled up. So the total overflow from submerging that 1,000 gram gray block, the total overflow, the total water displaced is 100 plus 12 or so milliliters. And because 1 milliliter is equal to 1 gram of water, 1 milliliter of water has a mass of 1 gram, we also know that our mass of this displaced water in these two graduated cylinders, the mass of that water is about 112 grams. I'm going to pour these back into our large beaker. the last part of part 2. We're repeating our water displacement investigation, but now we have our other mass, the golden one, which is 500 grams. Now we're going to lower that one into our large beaker and catch the overflow once again with our small beaker, and then take that overflow and put it into our graduated cylinders to get a more precise reading of how much water is actually being displaced, what volume of water is actually being displaced. Just making sure that guy's all the way topped off. My overflow, my big beaker is all the way topped off. My overflow is completely empty. I'm going to use make sure it's positioned under the spout, and I use my scale here to lower my 500 gram mass into the large beaker at a constant speed so I don't get any water coming out except from the spout until my whole golden 500 gram weight is submerged. Okay, and when I pull it out, watch, our water level is going to go down a little bit in our large beaker. And when we put it in again, our water level rises because our golden weight is displacing the water. And if I caught all the overflow, looks like there's a little bit left over. If I caught all the overflow, then nothing else is going to spill out. It'll go back up to the top without spilling. Okay, so now we have all the overflow or displaced water from the golden weight in our little collection cup here. So we're going to go right back to what we did before, find out how much exactly, what volume exactly was displaced. At a quick glance, it looks like somewhere around 50 milliliters, but this isn't a good enough measuring tool, so we're going to use our good graduated cylinders. So we'll use this one. Pour it in there, make sure we're not spilling any. Every last drop. Okay. And then I'm going to hold this over here, and we'll take our volume measurement for the displaced water from our 500 gram block. Got to be at eye level. We'll look for that meniscus and look for the bottom of that curve. If the camera will focus, let's back up a little bit. Alright, so we're reading off of a different graduated cylinder from last time, but you can see the 50 mark is the long line below the 50 number. And then I've got all those shorter marks are increments of 1 milliliter. So you decide where's the bottom of that curve on the meniscus. That's where you're going to read off the volume measurement in milliliters. To me, it looks like it's going to be something between 50 and 55 milliliters. You round it to where you see the bottom of that curve, which we call the meniscus. It's curving down somewhere right there. We're really zoomed in. Okay, and then that'll be the volume of our displaced water for our 500 gram mass. Remember that every milliliter of water is equivalent to 1 gram of water, so if we know the volume that is displaced in milliliters, we then also know the mass of that water, because 1 milliliter is 1 gram of water. That's in part 2. The last part of the, or final section rather, of the lab guide is to complete the reflection questions in here. The very last question in there is about density, which we've talked about calculating now. And remember that density is just the mass, the amount of matter, divided by the volume, or the space that that matter takes up. And we put in the units here, so if we want our density in grams divided by cubic centimeters, well, 1 milliliter is also 1 cubic centimeter, so 100 milliliters would be the same as 100 cubic centimeters. And so if we're getting our density in grams per cubic centimeter, that'd be the same as saying what's the mass in grams divided by milliliters. volume that we took when we were measuring our objects. And that is it. All we're submitting for this lab is the completed lab guide. That's all.